All right, we're seeing AI take this massive, almost science fiction leap. I mean, it's literally jumping out of our screens and into the real world. Today, we're going to dig into how Google's Gemini Robotics is basically giving AI a body, teaching it to see, to reason, and to actually do things right here in the same space we live in.
So let's just jump right in. We all know AI can be this incredible creative partner, right? It can write a song, whip up a poem, create some mind-blowing art. But what about something like this, folding a delicate, precise origami fox? This is where that digital genius suddenly slams headfirst into the messy, complicated reality of the physical world.
And that's really the heart of the challenge we're talking about. You know, an AI can be a world champion at a digital game, like chess. But if you ask it to just pick up a physical chess piece, suddenly it's a whole new ballgame. The real world isn't neat and tidy. It's unpredictable, it's cluttered, and it's run by the laws of physics. That's a huge hurdle for a brain born in the cloud. To even begin to solve this, an AI needs something called embodied reasoning. Honestly, you can just think of it as physical common sense. It's all that stuff we know without even thinking about it, like a glass is fragile, this is how you grip a tool, or yeah, that ball's gonna roll down a hill. This is the secret sauce for making robots that are actually useful. So, step one, you've got to build a specialized brain for the job. And that's where Gemini Robotics-ER comes in. The ER there stands for embodied reasoning. This is a version of the super powerful Gemini AI that's been specifically beefed up to see and, more importantly, make sense of our complex 3D world.
So what can this new brain actually do? Well, it can spot objects in both 2D and 3D. It can figure out the exact best place to grab something. It can predict where a moving object is going to go. And it can even fuse together what it sees from multiple cameras at once to build this really rich, detailed picture of what's going on around it.
Now this is where it gets really fascinating. They found a simple trick to make the AI even smarter. Instead of just asking for an answer, they prompted it to reason step by step first. It's a technique called chain of thought. And just by doing that, its score on a physical reasoning test jumped by more than 6%. It's literally learning to think before it acts. And you can see the payoff right here on this chart. A standard AI model, when thrown at a brand new task, only succeeded about 27% of the time. But this enhanced brain, Gemini Robotics-ER, it shot up to 53% success. It nearly doubled its effectiveness on stuff it had never seen before. That, right there, is the power of better reasoning.
Okay, so having a super smart brain is great, but it can't do anything without a body, right? So let's move on to the next piece of this puzzle, the action model. This is the part that translates all that thinking and understanding into fast, smooth, physical movement. And the way they built this is just so clever. All the heavy lifting, the really hard seeing and reasoning, that happens in the cloud on a massive AI model. But a tiny, super fast little action decoder runs right on the robot itself. This totally bypasses any network lag, letting the robot react and move smoothly in real time. We're talking 50 times a second. That's ridiculously fast.
So now we've got the whole system, a brain that gets it and a body that can do it. So how does this all-rounder robot actually stack up when you throw a bunch of different real-world challenges at it? Let's take a look.
First things first, the language. Does it actually understand what we want it to do? This chart makes it pretty clear. Gemini Robotics just blows past the other leading models. It's simply way better at understanding our messy, nuanced, and sometimes complicated commands.
And this is the crucial part. It's flexible. You can have a typo in your command, you can phrase it a totally different way, you can even say it in Spanish, and the robot still figures out what you mean. That is a massive step towards being able to just talk to a robot naturally. And it's not just about understanding words, it's about generalizing actions. Look at this. Gemini Robotics is way better at taking a skill it learned, like how to pick up a block, and adapting it to a new situation. Like if the block is in a different spot, or turned sideways, or is a totally different shape. It just adapts. So, being a great all-arounder is really impressive. But what happens when we need a robot to be a true expert at something? Let's see how this powerful general foundation can be fine-tuned to achieve total mastery on some incredibly difficult multi-step jobs.
And check this out. This is the kicker. Because it already has so much of that physical common sense baked in, it can learn a brand new, super complex skill with 100 demonstrations or even fewer. That is a game changer. It drastically cuts down the time and data you need to teach a robot something new.
And with that new expert skill, it can finally finally tackle our opening challenge, folding that origami fox. We're talking multiple, precise folds, sharp creases, and really delicate coordination between its two arms.
But it doesn't stop there. It can pull off a really long task, like packing a lunchbox. I mean, zipping open a bag, sealing a container, placing all the items, with a perfect 100% success rate in testing. That shows you just how reliable it can be.
And this might be the most impressive one. It can combine all its skills. It looks at a kid's drawing, recognizes the object, say a cat, and then physically spells out CAT with letter blocks. That's vision, reasoning, and manipulation all working together perfectly.
So just how good is it really? On that crazy hard origami task, the specialized Gemini model succeeded 45% of the time. Now, that might not sound like an A+, but look at the competition. It's 3 times better than other specialized models, which only got it right 15% of the time. In this field, that is a massive leap forward.
And get this core intelligence isn't locked into just one body. The same fundamental AI brain can be adapted to control totally different robots, from a standard 2-armed factory robot all the way up to the advanced Apollo humanoid. That shows you how flexible this system really is.
Okay, so as these robots get more and more capable and start to actually enter our world, our homes, our workplaces, one question starts to loom larger than any other. Are they safe? We have to look at how safety is being built in from the very beginning.
And we're talking about something much deeper than just not bumping into furniture. This is about semantic action safety. It's the common sense to understand context and consequence. It's knowing these basic truths of our world. This is about building robots that we can actually trust.
And this isn't just some vague idea. They're actively measuring it. On a safety test, the model already scores an 85% alignment with human safety judgments. And then, by adding what they call a safety constitution, basically a set of core principles, they can bump that up to 88%. They're making the robot's actions more and more aligned with our values.
So this brings us to the really exciting part. For years, we've been asking AI questions like, what is? Now we're shifting to telling it, please do. The limit is no longer just the technology. It's starting to become our own imagination. With robots this capable, this adaptable, and this safe on the horizon, the possibilities are just endless. So it leaves one last question for you to think about. What's the very first thing you would ask it to do?